Okay, now we're going to do the graphs, problems 29 through 34, I believe. I have the two main graphs, the parent graphs. This is the square root function, graph of the square root function. This is the graph of the cube root function. Each one of those is worth 1. Now notice that the square root function stops on the left here, but continues going upward like a half of a parabola on its side. Whereas the cube root function, it goes to the right and it goes to the left. It curves up here in the original, curves down, goes to the origin. Now, we plugged in points when we reviewed the graphs just the other day. I plugged in 0, 1, 4, and you might even plug in 9. I ran out of space. And down here I plugged in -8. This is -8 here, -1, 0, 1, and +8 to get the graph, to get enough points to get a nice smooth curve to show that. So the graphs you're doing are some transformations of these graphs. Like for example, the very first one here, number 29, it's a square root function, so it's going to look like this, except there's a -3 on the inside and a -1 on the outside. This slides it to the right 3 and down 1. These are translations. Now when I go to graph this, I make a T-chart. Excuse me, I make a T-chart and I plug in numbers in for x that are going to give me perfect squares. Like if I plug 3 in, I get the square root of 0. I can do that. If I plug 4 in, I get the square root of 1. If I plug 7 in, I get the square root of 4. So if I plug 3 in, I get the square root of 3 minus 3, which is the square root of 0, which is 0, minus 1 is -1. Make yourself some ordered pairs. You know the shape. Just get yourself started. Start with whatever makes this radical 0. Okay, for square roots. For 4, if I plug 4 in, 4 minus 3 is 1, the square root of 1 is 1, minus 1 is 0. Plug in 7. 7 minus 3 is 4, the square root of 4 is 2, 2 minus 1 is 1. And then you can get an idea of what's going on here. Let me use a different color here. Let's try, I got a purple one here and a green one. Let's try the green one here. I plug 3, -1 down here. I plug in 4, 0. Make sure you plug the points in right. Make sure X, right, left, Y, upward, downward here. 4, 0, and then 7, 5, 6, 7, 1. Be about like that, and you know what the curve looks like. It looks like this. And there's my graph. Okay? The points help me a lot. Now over here, this is the cube root, so it's going to look kind of like this guy here, where it's extended in both directions, except that you can see from the parent, it's been shifted to the right 2 up 4. To the right 2 up 4. Now what are your perfect cubes? -8, -1, 0, 1, 8. Those are all perfect cubes. Look at the T-chart I made here. I picked X values that make this a perfect cube. See, if you put -6 in there, -6 minus 2 is -8. The cube root of -8 is -2. Plus 4 is 2. If I plug 1 in, 1 minus 2 is -1. The cube root of -1 is -1. Plus 3 is 3. Plug 2 in. That's a good one because that's where it does the little hitching to get along. It's called a point of inflection. And in this case, if I plug 2 in, 2 minus 2 is 0. The cube root of 0 is 0 plus 4 is 4. If I plug 3 in, 3 minus 2 is 1. The cube root of 1 is 1 plus 4 is 5. If I plug the last one, 10 in, 10 minus 2 is 8. The cube root of 8 is 2 plus 4 is 6. I've got enough. I've got enough to come up with a halfway decent sketch. Because I know what the shape looks like. That's key. You've got to memorize those. So -6, 1, 2, 3, 4, 5, 6. -6, positive 2. 1, positive 3. 2, 4. Look at this. Look at this. Right? 3, 5. 1, 2, 3, 5. 10, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 6. Best I can approximate it there. So there's my curve. It goes down like this and up like this. That's kind of sloppy. Use a pencil. Use a pencil. Otherwise you're going to get something sloppy like what I just put up there. Be as neat as you can with the graphs. Here's another cube root. And there's another translation. See the -2 inside? That means you're shifting it 2 to the right. But what does this 3 do? It doesn't mean it's raising it. This means it is stretching it by a factor of 3. So you're going to get some bigger y values and smaller y values. So again, I'm plugging in numbers so that when I subtract 2, I get perfect cubes. Well, see, I had the -2 here. I have the -2 here. I use the same one. See how they're the same? So if I plug -6 in, -6 minus 2 is -8. The cube root of -8 is -2 times 3 is -6. If I plug 1 in, 1 minus 2 is -1. The cube root is -1 times 3 is -3. If I plug 2 in, 2 minus 2 is 0. The cube root of 0 is 0 times 3 is 0. If I plug 3 in, 3 minus 2 is 1. The cube root of 1 is 1 times 3 is 3. And if I plug 10 in, 10 minus 2 is 8. The cube root of 8 is 2. 3 times 2 is 6. Now remember, this part's the same. So it's going to look like this, except it's going to be stretched out. Well, this got actually raised up for, but it's going to go right through the x-axis here. So -6, -6. 1, 2, 3, 4, 5, 6. -6. 1, 2, 3, 4, 5, 6. -6 here. So I'd be down here, best I can. 1, -3. 1, 1, 2, 3 down here. 2, 0. 3, 3, and 10, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 here. 10, 6, 1, 2, 3, 4, 5, 6. Do you see how it got stretched out this way? It's not so skinny, it's going to be much wider, but it's still got that same shape. Okay? And that's the graph of that one. Now, 32 over here, I'm going to, again, oh, where did I lose my pen? There it is. I'm going to pick x values here. This is a square root. Kind of look like that guy. I'm going to pick values that make this perfect squares, like 0 and 1 and 4 and 9. If I plug -6 in, -6 plus 6 is 0. The square root of 0 is 0, plus 3 is 3. If I plug -5 in, -5 plus 6 is 1. The square root of 1 is 1, plus 3 is 4. If I plug -2 in, see how I pick these values? -2 plus 6 is 4. The square root of 4 is 2, plus 3 is 5. If I plug 3 in, I get the square root of 9, which is 3, plus 3 is 6. So remember, I know what the shape is. It looks like this. The only difference here is it's been shifted to the left, because it's plus, under the bracket. To the left 6 and then up 3. So let me graph this one. To the left 6, -6, 1, 2, 3, 4, 5, 6. This is -6. 3 would be up here. It's going to look like that, probably something like this. -5, 4, -2, 5, 1, 2, 3, 4, 5. And then 3, 6. It does look like that. Can you see it? Now don't put an arrow on the left side. It's only going to go on forever the right side. You can't plug any of these numbers in. It'll give you the square root of a negative number. That's imaginary. And we're graphing reals. Okay. Got a tricky one. Got a negative in here for problem 33. It's a cube root. Now remember what the negative is going to do. It's going to reflect it in the x-axis. Now you don't have to worry about knowing exactly how to reflect it, as long as you pick good values in here to get that shape. Now if it's reflected though, instead of kind of going up and then down to the left and up to the right, it's going to go up to the left and down to the right. You'll see that as we graph it. Plugging in some values. Again, I plugged in values here. I picked these because they gave me perfect cubes. -4 minus 4 is -8. The cube root of -8 is -2. Times -3 is +6. Plug 3 in. 3 minus 4 is -1. The cube root of -1 is -1 times -3 is +3. Plug 4 in. 4 minus 4 is 0. The cube root of 0 is 0 times -3 is 0. Plug 5 in. 5 minus 4 is 1. The cube root of 1 is 1 times -3 is -3. Plug 12 in. See, I picked numbers that give me perfect cubes because 12 minus 4 is 8. That's a perfect cube. The cube root of 8 is 2 times -3 is -6. So now I'm going to graph this beast. I'm going to graph negative 4, 1, 2, 3, 4, positive 6, 1, 2, 3, 4, 5, 6. I put a little 6 there to remind me. There's 1. Then 3, 3, 3, 3. 1, 2, 3, right about here. Then 4, 0. Then 5, negative 3. 5, 1, 2, 3 be down here. And then 12. 1, 2, 3, 4, 5. This is negative 6 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be 12, negative 6. It'd be about here. So I get my graph. Do you see how it's going up and to the left and down and to the right? Do you see how it's been stretched because of the 3 been reflected? So now I just try to do my best to make a nice smooth curve. And again, use a pencil so you don't mess it up, and then can't erase. And there's my graph. Oh, missed. There I made it. All right, there's one left to do, but I'm kind of out of space here, so I'm going to kind of cheap out, and I'm going to come over here to this set of axes that I used before for the parent graph, and I'm going to go ahead and see if I can squeeze him in here, and that is a square root. It is, let me grab my black pen here. Y equals negative 1 minus 2, the square root of x plus 5. Right. Well, this is a square root. There's a 2 times it. That's going to stretch it. And there's a negative or a minus in front of it. That's going to reflect it in the x-axis. It might end up going like this. And there's a negative 1 out here. That's going to drop it down 1 unit. That's a lot of stuff to keep track of. I'm just going to create a table of values here to help me out. I'm going to start with the number that makes this 0, which is negative 5. And then I'm going to use negative 4, because then I'll get 1, and I can take the square root of that. And then I'm going to use negative 1, because I'll get 4, and I can take the square root of that. And if I want to get really fancy, I'll plug a 4 in there, because 4 plus 5 is 9, and I can take the square root of that. I got a feeling the values are going to get kind of big here, though. So now, what do I have? If I plug negative 5 in, negative 5 plus 5 is 0. Square root of 0 is 0, times 2 is 0, negative 1 minus 0 is negative 1. Plug negative 4 in. Negative 4 plus 5 is 1, the square root of 1, times this 2 here would be 2. Negative 1 minus 2 is negative 3. Be very careful with your order of operations. Negative 1 in here, plus 5 is 4, the square root of 4 is 2, times this 2 is 4, so I have negative 1 minus 4, that's negative 5. Looks like it's dropping down here by 2's. And I'll plug 4 in. 4 plus 5 is 9. The square root of 9 is 3 times 2 is 6. Negative 1 minus 6 is negative 7. Yeah, I did not make this graph big enough as far as the y values, because it drops way down here. So 1, 2, 3, 4, 5, 6, 7. Let's see if we can squeeze her in now. Negative 5, each one of these is 1. Negative 5, negative 1. Negative 5. 1, 2, 3, 4, 5. Negative 5, negative 1 would be right here. That's the end point. That's what makes it 0. Negative 4, negative 3. Oh, this is different. Not going up, it's going down because it got reflected with this minus sign in front of the 2. Negative 1, negative 5. 1, 2, 3, 4, 5 would be over here. And see how fast it's dropping down? The 2 stretched it. And 4, 1, 2, 3, 4, negative 7. Yeah, it'd be about like that. Here we go, guys. And your graph is going to look like that in green. It's going to stop right here. Don't put an arrow on the end. Arrows on the ends for the cube roots, not for the square roots. Only on the one side on the square root. And that's your graphs. Now, a couple of these were pretty tricky, so if you have questions, I'll be happy to help you with that. But give them a try prior, of course, to working the problems out. And good luck with your review.